All right, so right now we need to talk about functions. Okay, so question. Does anybody remember what a function is? In other words, if I wanted to write a definition here, I would write something like a function.
It's an equation that always has one output for every input.
Super close. I'm not willing to go as far as equation.
It is a thing that has one output for every input.
Is a thing.
Is a thing. I'm going to call that thing a rule, right? So it's a rule associating inputs to outputs with each input associated to one and only one output. You guys with me on that?
Yeah.
What's this business about one and only one? Like, if you think about this thing as a machine, right? Like, this is kind of the classic picture that goes with this. There's like an in and an out, right? And like some kind of like nonsense going on in here.
It's nice nonsense.
Don't raise your hand, just talk.
Oh yeah. So having one and only one output makes it so if you reverse it, you can get the same. You can get like your answer correct still.
Yeah, so that would be great. That would be something called function inversion, right? Like we could back out of this rule, and that's not necessarily the case.
Okay.
Right? Because even though each input is associated to one and only one output, that doesn't necessarily mean that there aren't two inputs with the same output. And then I wouldn't know how to back out of it.
Right. That makes sense.
You guys see that?
Yeah.
So what's this, like, what is it doing quite, like, so let's just decompose this into its two pieces, right? Let's just say each input's associated to one output, right? What does that mean?
It means that anytime you put an input, no matter how many times or when you put it in, you always get the same output.
Yeah. That's a really good explanation of the one and only one, right?
Mhm.
Like, you put an input in, and it always does the same thing, right? It's not a gumball machine, right? A gumball machine is a rule, right? It's not a function, but it's a rule, and it takes quarters and turns them into random bits of crap, right?
Yeah.
Like sometimes it turns them into, you know, like a little plastic figurine in a bubble, and sometimes it turns them actually into a gumball, right?
Yeah.
But that's not predictable, so I don't want that. So the thing I want you to take from this one and only one output business is that a function is not a gumball machine. You guys cool with that? There's no element of randomness. If you put the same thing in later, you'll get the same output. You guys cool with that?
Yeah.
Okay. So then we need a couple of associated words. I just want you to recall these because I think you've probably seen them before. What's a domain? And what's a range?
X is domain.
The domain is all the x values and range is all the y values.
Domain is
or
the
inputs for domain and outputs for range.
Yeah, that's what I want.
Yeah.
The domain is all the inputs, right? All possible inputs. And the range is all possible outputs. And I'm lying to you just a little with that. Don't sweat it for now. When you take linear algebra, we'll talk about exactly where that is. So there's a slight lie here, right? And what I'm kind of mumbling is that mathematics is a series of like, we'll go through and reveal the lies to you that we taught you last time. Like, and at each stage, we just like take away a little bit of the lies, right? So if you want to find out what the lie is here and remove it from your brain, you'll have to take linear algebra. If you're okay with this, fine, awesome. That's the level I need you to be at for this class. Cool?
Yeah.
All right, so, I'm going to tend to draw this a little bit differently. Like, I'm not going to draw this funny machine picture every time. When I want to draw a function on the board, I'm going to do this. I'm going to draw a blob, make an arrow, and draw another blob. Cool? I'm going to call, like, this maybe f, say. Right? For function. And this might be an x over here is a little dot, and that little dot gets pushed forward to an f of x over there. This notation's hopefully pretty familiar. Maybe the bubbles aren't. The bubble's a little new. Okay, so the reason I use the bubbles is if I want to think about functions in steps. So like you guys know some steps. Maybe let me think about a function g of x that's 2x plus 7. Right? Okay, this is a function you know about, right? Like you guys probably know how to do lots of stuff with this function.
Yeah.
Okay, so tell me, how would you do this function to an x? Like what would your first step be? Yeah, you'd first multiply by 2, right? So my first step in my bubble would be multiply by 2. You guys see that?
Yeah.
I am not drawing the function g here, right? G is not this arrow, because g does more than multiply by 2. What does it do after it multiplies by 2? You add 7, right? You guys with this?
Yeah.
So where's g in this picture? Yeah, good. G goes from this first thing to the last thing, right?
Right.
You guys see that? So when I'm trying to do, like, especially computer science stuff, I have some algorithm. And what an algorithm is just a bunch of function steps, usually. And so what I want to do is I want to decompose that algorithm into its constituent parts. So I'm getting you guys some practice with things like that by decomposing our functions into their constituent parts. Part of the reason for that is that I can come up with that inverse function that you wanted a minute ago pretty easily here. You guys see that?
Yeah.
Like, if I want to back out of this thing, what do I need to do first?
Subtract 7.
Nice! You all got to subtract 7 instead of, what was the other thing you need to do to back out of this? You need to divide by 2. You guys see that? So let's, just for kicks, write down g inverse of x. So you're going to start with a x, right? And then what are you going to do to x first to back out?
Subtract 7.
You need to subtract 7. And then what do you need to do?
Divide by 2.
So what do you divide by 2?
The
X
difference.
minus 7.
Yeah, the whole thing. Perfect. You guys see that?
Yeah.
You guys are on the ball. This is going to be an easy pre-calculus class. Cool? Questions, things? Okay. All right. This is the basics that I need you to have for functions just right now so we can all talk the same language. A function's a rule associating inputs to outputs. Each input's associated to one and only one output. The domain is all the possible inputs. The range is all the possible outputs. And if you want to invert a function, you go backwards. You guys all good with that?
Yeah.
And the way you go backwards is you do the opposite steps in the opposite order.
Okay.
You guys good with that?
Mhm.